So in this video, we're going to talk about how to graph functions, a bunch of various types of functions, including linear functions, quadratic functions, which make parabolas, absolute value functions, which make v's, cubic functions, which are like s's, and then radical functions, which just kind of shoot off like a helicopter or a jet might shoot off. And so let's go ahead and get started with them. There are 5 examples we're going to do in this video. And the first one looks like this. We have y equals 2x plus 1. We have our domain values here. We have our range values here. And so we can stick in anything that we want for our domain values. And usually when there's nothing there to help guide us, I would suggest maybe plugging in like -2, -1, 0, 1, and 2. And so we can do some of this mentally, but we're going to do the first one by showing our work here. If -2 is the domain, that means we're going to have -2 not times x, but times -2 plus 1. And -2 times -2 is 4, and 4 plus 1 is 5. So then, if I plug in -1, I'll have -2 times -1, which is 2. 2 plus 1 is 3. If I plug in 0, -2 times 0 is 0, and 0 plus 1 is 1. If I plug in 1, then -2 times 1 is -2, and -2 plus 1 is -1. And then if I plug in 2, -2 times 2 is -4, and -4 plus 1 is -3. So this is a -1 here. So then if I plot these points, -2, 5 means I would go to the left 2 and up 5, which means I'm at this point. -1, 3 means I go left 1 and up 3. 0, 1 is here at this point. 1, -1 is here. 2, -3 is here. And we get a pretty good idea of what this looks like from plotting those points. It's going to be a line that would continue on in both directions forever, that would look something like that. Now if I had a ruler, I would make this look a little bit better, but that's what this graph looks like. We call these linear functions because it makes a line. And so anytime we just have like something where we're multiplying something by x or adding something to x, that's going to be a linear function. We're going to learn that this is of the type y equals mx plus b. And our next unit that we're going to talk about is strictly about linear functions. So we're going to get to know these type of functions very well. Let's take a look at number 2. This is a little bit different. It's not linear because it also has this x squared term. And so in here, in our set of domain values, they're helping us out by putting a 1 in the middle. And so we're going to start with 1 in the middle, but then we're going to choose, like 1 is here on the graph. We're going to choose numbers to the right and to the left of 1. I'm sorry, here's 1. We're going to choose numbers to the right and to the left of 1 also. Like to the right is 2 and 3, and then to the left is 0 and -1. But if I start with 1 and I plug that in, it's going to be 1 squared minus 2 times 1 minus 1. 1 squared is 1, minus 2 times 1 is -2, and then -1. Well, 1 minus 2 is -1, and -1 minus 1 is -2. So I'm going to plug in, let's say, 0 next. If I plug in 0, x squared is 0, minus 2 times 0, that's 0. So it's like we have a 0 minus 1, which is -1. At the same time, I'm going to plug in a positive 2 here. 2 squared is 4, minus 2 times 2, minus 1. Well, that's 4 minus 4 minus 1. 4 minus 4 is 0, and 0 minus 1 is -1. If I plug in, let's try a -1. This is going to be -1 squared minus 2 times -1 minus 1. Well, -1 squared is 1. Then a -2 times a -1 is positive 2 minus 1. Well, 1 plus 2 is 3, and 3 minus 1 is 2. And so when I plug in a 3, I'll have 3 squared, which is 9, minus 2 times 3 is minus 6, minus 1. 9 minus 6 is 3. 3 minus 1 is also 2. So when I plot these points, I have a point at negative 1, 2, which is here. I have a point at 0, negative 1, which is down here. I have a point at 1, all right, so I am going to fix what I just said earlier. I had to clear the graph a little bit so I wasn't getting confused with everything that was on there. We have a point at negative 1, 2, which is right here. Then we have a point at 0, negative 1, which is here. Then we have a point, 0, negative 1 is here. Then we have another point at 1, negative 2. I go over 1 and down 2. Then I have a point at 2, negative 1, which is here. Then I have another point at 3, over 3, and up 2, which is here. So if we plotted more points, you might be able to see this a little bit better. But we are going to have a shape, a graph that looks something like that. I should have hit this point a little bit better here. But that is what's called a parabola. And that is what we get whenever we have what is called a quadratic function. A quadratic function is always what we get whenever we have an x squared term. And a quadratic graph is in the shape of a parabola. And we're going to talk a lot about parabolas during the second semester. But sometimes they'll open up, sometimes they'll open down. Let's take a look at the next type of graph. So here we have another type of function. It's not a linear function because it has absolute values there. It's not quadratic because the x is not squared. So let's just plot some points and see what's happening here. Again, we're starting at 2, but we're going to go to the right of 2 and plug in a 3 and a 4. Go to the left of 2 and plug in a 1 and a 0. But I'm going to start by plugging in a 2. If I did plug in a 2, absolute value of 2 minus 2 minus 1. Well, 2 minus 2, that's 0, and 0 minus 1 is negative 1. If I plug in, let's say, a 3, then it's going to be the absolute value of 3 minus 2. 3 minus 2 is 1, and then 1 minus 1 is 0. If I plug in a 4, it's going to be the absolute value of 4 minus 2, which is 2, and 2 minus 1 is 1. If I go the other direction and I plug in a 1, then it's going to be the absolute value of 1 minus 2 minus 1. Well, 1 minus 2 is negative 1, but the absolute value of negative 1 is 1, and 1 minus 1 is 0. If I plug in a 0 for x, then 0 minus 2 is negative 2, but I take the absolute value of that, which gives me positive 2, and then minus the 1 gives me 1. So if I plot these points, I'll have a point at 0, 1, which is here. I'll have another point at 1, 0, which is here. I'll have a point at 2, negative 1, so I go over 2 and down 1. Looks like they're in a straight line so far, but then all of a sudden 3, 0 is here. And then I have another point at 4, 1, which is here. And so what's happening is I have a graph that looks something like this. And I could plot more points. If I plugged in a 5, it would give me a 2. If I plug in a 6, it'd give me a 3. But you can see that that is the shape of, it looks like a V. And we call these absolute value functions because there's an absolute value in the rule. And if there's a absolute value function, it's always going to be in the shape of a V. Now, sometimes that V will be upside down. It'll look more like an A. But whenever we have a graph that looks like that, or a function rule that looks like that, the graph will be in the shape of a V. So we've had so far linear functions, quadratic functions, absolute value functions. Now we're going to take a look at this type of function. It's not linear because it's not just an x, and it's not quadratic because a quadratic function is x squared, and this is x to the third. And so something's going to happen that's a little bit different here. We're going to start by plugging in a 0. Let's just plug that in first. If I have 0.5 times 0 to the third power, well, 0 to the third power is 0. And then 0.5 times 0, that's just going to give me 0. So we have 1 point here at 0, 0. But I'm going to plug in points around this like 1 and 2 and negative 1 and negative 2. So let's say I plug in 1. It's going to be 0.5 times 1 to the third. Well, 1 to the third means 1 times 1 times 1. 1 times 1 is 1 times another 1 is 1. That's just 1. And 0.5 times 1 is 0.5. And so this is 0.5. If I plug in a 2, well, if I plug in a 2, it's going to be 0.5 times 2 to the third. And so 2 to the third means 2 times 2 times 2. So 2 times 2 times 2. 2 times 2 is 4. Then I'm going to take that 4 times 2, which is going to give me 8. So this is like 0.5 times 8. That's half of 8, which is 4. 4. So if I plug in, let's say I plug in negative 2. Well, it's going to be 0.5 times negative 2 squared. Well, negative 2, to the third. Negative 2 to the third is same thing that I had up here, except these 2's are negative. Negative 2 times negative 2 is positive 4, but positive 4 times negative 2 is negative 8. So this is going to give me negative 8 right here. And if I plug in negative 1, 0.5 times negative 1 to the third. Negative 1 to the third means negative 1 times negative 1 times negative 1. Well, that's going to end up being negative 1 times 0.5, which is negative 0.5. Negative 0.5. And if I graph these points, I have a point at 0, 0, which is already on the graph. I have a point at negative 2, 8, which is going to be way up here. I'm going to have another point at negative 1 and, this is not 8 right here. This should be 4. I did this one wrong. This one should be negative 4. And here's why. Negative 2 times negative 2 times negative 2 is negative 8. But then when I multiply it times 0.5, that should be negative 4. And so this point's not on the graph. Let me erase that. And I'm going to put that at negative 2, negative 4, which is here. Then I have a point at 1, negative 5, or negative 1, negative 5, which is negative 0.5, which is about there, about a half. Then if I plot this point, it's 1 and 0.5, which is about right there. And then I have another point at 2, 4, which is about here. So this is a little bit different of a graph. It kind of looks like this. It goes and then it kind of curves and then it goes back up again. Kind of like an S in a way. That is a graph that is called a cubic function. It's a cubic function because we're raising it to the third power, and we always get sort of like an S-looking graph when we graph those cubic functions. Let's take a look at one more. If I were to take a look at this graph, and I start by plugging in negative 2, negative 2 plus 2 is 0. The square root of 0 is 0, plus 1 gives me 1. If I plug in negative 1, then the square root of negative 1 plus 2 is 1. Square root of 1 is 1, plus 1, this gives me 2. If I were to plug in 2 here, then 2 plus 2 is 4, and the square root of 4 is 2. 2 plus 1 is 3. And if I were to plug in 7, then 7 plus 2 is 9, the square root of 9 is 3, and 3 plus 1, that's a plus, 3 plus 1 is 4. I can't plug in a negative 3 because if I try to plug in a negative 3, it'll be a negative 3 plus 2, which is negative 1, and I just can't take the square root of a negative number. So this graph is actually going to start at the point negative 2, 1. Then there's going to be a point at negative 1, 2, another point at 2, 3, and another point at 7, 4. And it's going to look something like this. It actually starts right here at this point and then just kind of shoots off to the right like that. We call this a radical function, and the graph is always going to look something like that. Now sometimes it'll go up, sometimes it'll go down, but it'll always be shooting off to the right somehow. So these are the 5 different types of graphs that we're going to have on our homework assignment. If you need help with any of them, you can refer to this video, and we will talk more about it tomorrow in class.